Another MLOps meetup. Thank you all for joining us. This is really exciting. Saurav, I will just start by asking you if you can give us an idea of how you came to be where you are right now.
So I would say I just wandered my way into all of this. Some years ago, I started off as a regular statistics person, doing statistical analysis across products. Then the big data revolution sort of happened. I did some work in that, and then slowly the area of machine learning caught up, and there was at some point some divergence between machine learning and statistics, I guess. And I was always a very big tinkerer of sorts. I kept on doing stuff. So eventually, I got into machine learning, and as I gained a little experience in this field, I started solving some abstract problems in the area of machine learning. So as probably all you guys are aware, the area of MLOps, model fairness, bias in the machine learning space are some of my favorite topics to think about, to talk about, to write about.
Perfect. So now today you came to me with this talk title or this theme that is the MLOps, the elephant and the blind men. And I think it's a great analogy for what we're doing right now and where the state of ML is. And I just wanted to get your idea of where you feel machine learning is right now and how you feel MLOps is.
Yeah. So I'm sharing my screen, and I can just run through a couple of slides. So basically, when I was thinking about what to talk about in this forum, I realized that, of course, the participants are great, and you have some great speakers. So I was a little nervous about what to talk about. So I thought maybe one example could be based on my experience working with different types of customers. And what do I see? How do I see different people perceive MLOps as? So this idea of this is an old story. It probably is a Buddhist Indian story where a bunch of blind men start to understand what an elephant is by touching various parts of the elephant. And of course, I'm sure you guys know this story. And somehow when working with clients on MLOps, I realized most of my customers also thought of MLOps in this particular way. So what kind of blind men did I encounter? And I'm not saying they don't know anything. They are probably very well versed with their domain. But when it comes to the way they define MLOps, it changes, right? So then I met a bunch of people who are business analysts with coding skills. So they are called upon to do the analysis for their teams, like a supply chain analyst or a marketing analyst or folks of that nature. Not core machine learning guys, but they use machine learning techniques. They use forecasting, they use regression, they do clustering, and so on. Their software skills are low, but their business or domain understanding is very, very high. The challenge with these folks is they are ready to sacrifice reproducibility for speed. So most of the time, these analysts, they want to get to the point very quickly. And they are happy to, even if everything is not 100% reproducible, they're happy to get their results and move ahead. They may not care so much about production level environment, production level code. And for these people, MLOps is a significant change, and basically it has no value. So this is one kind of.
Really, for these people, it's like they just want to prove out the business value.
Yes, they just want to prove out the business value. They're happy using their sets of tools, techniques, and just going about their business. I mean, they are more interested in what is the revenue forecast for the next month rather than how did they go about getting to that, right? And these people, for them, the idea of DevOps is alien. Putting MLOps on that is even more complex. And because they haven't been software engineers for any period of time, some of these concepts are also difficult. But they are a large part of they're large users of the systems that we built, because these are the guys who mostly take information like this and take it to the leadership, take it to the management teams. The next type of people I encountered were pure software engineers. So for them, DevOps, MLOps is bread and butter. They know these things very well. They are not very familiar with the business or the domain. They have a strong bias for production level code. But these software engineers have a little bit of a problem, and that is they are not very experimentative when it comes to things. So they are not the natural tendency is to not to interrogate the data and try to find patterns, do some analysis. They are happy writing good quality production level code. If it's machine learning code, it's machine learning code. If it's integration code, data code, and then they want to ship things into production. For them, so if you take the continuum between experimentation and maybe not experimentation, let's say the continuum between explore and exploit, they're on the exploit side of the continuum. The next set of people that I encountered was who were engineers in ML products, and these are the classical, sort of developers of the whole idea of MLOps. They are good software engineers, they are good machine learning guys, and they are already hacking their way to MLOps. So even before MLOps as a term was known, most of these guys were writing code which worked in a CI/CD environment, which had their own built-in testing mechanisms and so on. The final bunch which I encountered were these classical data scientists who were somewhere in between the business analyst and the machine learning engineers. They had the strongest pain of moving code from dev to production. I mean, these were the guys who developed meaningful machine learning work products. And then these were the guys who were tasked with the job of ensuring that it moves to production. And these were the people who kind of, I saw them adopt machine learning ops with the most enthusiasm. And I realized that they had the significant pain. So I was working with a team. They would develop their models in R or Python, let's say, logistic regression. And then they would convert this whole thing into a Java code, or even into a SQL type code where the model parameters were included as a SQL code, and they would work months with the dev team to ensure that their machine learning work goes into a production pipeline. So for them, I think MLOps came as a big boon, because a large part of the post machine learning let's say model build went away in terms of their workload, and they could focus most of their time on doing new experiments. So these are the sort of four types of users of machine learning that I encountered, and each of them looked at MLOps in a different way. The data scientists looked at MLOps as something which saves their time. The business analysts looked at MLOps as something which was a pain for them to work on.
On that note, for these software engineers, because we were talking with Charles yesterday about how maybe sometimes you have software engineers that they know how to do things, and they complete their stack and they create a stack that is really, it works well, but then if they need to move outside of that, then you encounter some pushback. Have you seen that at all?
Right. So let me give you an example of one financial service customer that I work with. They're in a B2C financial service. They have two major machine learning applications, right? And each of these machine learning applications in turn consist of a bunch of smaller machine learning models. And each of these models would have in turn a few experiments running in parallel. The challenge for them was that the idea to experiment, I'm sorry, this is a typo here, idea to experiment to production was about 6 months. So let's say I have an idea, I want to do a simple thing. I never had a model which included zip code as one of the uh, variables, and I want to add that and rerun my experiments and deploy that to production. It would take me 6 months to get to production. The typical feature engineering process would take 2, 3 months. A new SAS, R, or a Python module, and they had different environments which they would use, and that would be about a month. Then they would spend some time recoding either in SAS to SQL or something like that. A/B testing is 1 2 years because it's a financial services. So whatever you do, you see the results of that coming in over a period of time. So they are basically hamstring in this whole thing, and they had very good folks who were working on this tax. So the way we architect the system for them was um, we created a new feature store using Spark, ETL, and Airflow. We use data lake on Azure to have all of these, and we persisted the data lake on a SQL server, ETL for all the data lake for all the ETL jobs. We developed an MLOps using the Azure Stack. So in this particular case, we use Azure Stack to do most of the work. So Azure Machine Learning Services, etc. The challenge in this case, and I think this relates to your software engineering principle, when we started off this work, the data is not completely available in the dev environment. Some reason for this is security, compliance, etc. And some reason is dev environment is not supposed to have all the data. And that is a very software engineering mindset, right? You get sample data so that you can basically test your code, develop your basic stuff. The actual work happens in prod environment. But machine learning doesn't work that way, right? I need feedback for the model that I have developed. I need the information on accuracy. I need information on stuff. ASAP, I need it right away. And that is not available for me because I check in my code, the code gets promoted if everything goes okay to the next environment. In the pre-prod or the testing environment, it gets integrated. Then the production code, I can't wait for that. So converting that mentality and InfoSec came into picture, general engineering stack came into picture, converting that into a mindset where everything should happen. There is no, we can't have a separate dev data set and a prod data set and expect the things to work in the same way. It was a big shift in the way most of the teams thought, right? And that that the changing that thinking was a big exercise which we had to sort of develop. And you're right, most of the engineering team, it's a little bit of a rewiring, right? That a well-written code, for them, a well-written code written in dev will work the same in prod. For a machine learning person, it doesn't matter. I mean, whatever data you throw in dev, if the data which comes in prod is different, the model, the system doesn't work. So that kind of required a little bit of a change management.
That's a great point. That is, yeah. It echoes what we were hearing yesterday from Charles too, and how you can run into problems with that. And so, were they able to eventually get the full data sets to train on? How did that work out?
Yes. So in this context, I think because of GDPR compliance related issues, etc., we couldn't have the data available in the dev environment. But what we managed to do is to separate out the training run process from the code build process. So it kind of hampered a little bit because the error signals are a little bit delayed. But the way we did is every time you have to check in the code for your training run to run. There is no notebook-based experimentation which is possible. But as soon as you check in the code, which goes into your it triggers your pipeline, and once the pipeline is triggered, your model build process starts. And once the model build process is complete, you get to see the reports in real time. Even if you are not seeing the data in real time, you get to see the metrics and other information in real time. And we created a separate environment which is allowed for certain users who can conform to the rules and regulations as per GDPR, and they could actually do live work with the data. So basically, we split it into two different components. In one piece, the training code writing and the training process are a little different, are separated out. And in one environment, you can do both of them kind of simultaneously.
Great. I don't want to derail what you have planned, but I have a few questions about the blog article that you wrote. So are you finished here with this stuff, or do you want to keep going?
No. I'm mostly finished here. I mean, there was a couple of slides on what we did, but I think we have covered all of them. So I'll just stop sharing, and then you can shoot your questions.
Great, yeah. And the main thing, so if anyone hasn't read Saurav's blog article about MLOps and reducing the technical debt of machine learning, it's a great read. I think it's really informational when it comes to putting together your own MLOps pipeline with the open source tools that are out there right now. And so I wanted to dive into the whole open source idea, because this example that you show us, they were using Azure and Databricks. So I imagine you didn't encounter a lot of problems that you may encounter if you're just trying to go 100% open source and build it yourself.
No. So there are two types of customers. There are certain customers who have a strong engineering mindset. They want to own the engineering systems processes themselves, and they have, or they want to build a strong infrastructure engineering team. And they are happy to do the way I wrote in the blog. They are the ones who would hack together a bunch of open source tools. And they, by the way, just as an FYI, I don't know if it's public information or not, but for example, MLflow is the engine which runs Azure's machine learning services. They are using MLflow somewhere in the backend. And the customers who have that engineering DNA in them or want to build them, they are happy doing it this way. Many customers, specifically enterprise customers who want to use MLOps, who want to adopt MLOps for their business processes, but don't want the overhead of managing the system, they're perfectly fine with using some of these cloud-based services.
And going back to that whole security aspect, do you see a difference, or is it more difficult to get something through if you build it yourself and you need to then talk to the InfoSec people or the DevOps people, or is that something that you haven't really noticed?
Oh no, actually, doing it yourself is significantly complicated. So I ran into issues with in one of my own projects, where, for example, when you spin a server, a virtual machine, and do your, let's say, host your MLflow server on that, who takes care of the patches and securities and so on for that particular virtual machine that I'm spinning? And the InfoSec people, they ask very strong questions, very complicated questions around that point. So unless I'm ready to take the whole ownership of ensuring that the VM is there, it's patched properly, the MLflow server is upgraded according to whatever policies we set up, it's difficult. It's easier in today's context to use a service which is managed by somebody else, like Azure or DocScience or any of these products that you have, because they for the internal InfoSec people, it's just less headache.
Yeah, and that makes total sense. I can see that. And looking at it, you would need, I'm sure it's not the data scientist who's hacking this all together. Like you said, there's, the data scientist has their focus and they're primarily building models. So it would be someone who's more of that hybrid role or that ML engineer role, or you have to build a team of people. But I'm wondering how heavy of a lift it is, and is it something that's feasible? Did you do it by yourself, or did you need help from software engineers?
No, I kind of put everything together by myself. But you have to remember that I am not whatever you see. It's sort of trivial to put together. I mean, you can read the documentation for all these products. MLflow has a great documentation. DVC has a great documentation, and you can put everything together, and it'll work. But have I considered fail-safe? Have I considered backup? Have I considered the patching of all of these things? Have I firewalled it properly? These are questions which I'm probably, as a data scientist or even as an ML engineer, I'm not even conscious of these kind of questions. This is a separate network security infrastructure maintenance domain, which I'm absolutely ignorant. So I'll not pretend that I even understand what kind of complexity goes in there. So, but otherwise it's trivial. I mean, I can just install a server there, connect it to this, spend some, create some APIs. What if it gets audited? I'll be caught.
Yeah, yeah. So it's like it's easy to hack something together, but once you need to really get it out there on the production level, it's a whole different story, and you need to push it through all the different sectors of the company. Yeah. So I see there's a question in the chat, and Naveed is asking, what is the most preferred MLOps service for data scientists? User groups who are into modeling and comfortable with R and Python, but are completely new to DevOps. So that, I guess that would be the data scientist kind of profile that you explained earlier.
Right. So I think most of the services that we have today have a reasonably matured system which abstracts a lot of these DevOps from the ordinary user. So as I said, I'm a little familiar working with the Azure stack. I have also tried out the DocScience workflow. I've seen a little bit of the AWS's stack. And there was another company who reached out to me. I'm forgetting the name, but they also have a reasonably good system. Then you have good tools like I'm sorry, I'm forgetting the name. But so these have reasonable level of abstractness built into the idea of DevOps. So as a data scientist, if you use any of these tools, you will not have problems. I mean, the engines in the backend would take care of the whole, or to a large extent, the DevOps bit of it. But if you want to go to a little next level when it comes to designing some of these systems, then I think knowing DevOps becomes a little important. That, for example, the problems that we were discussing, how do I give access to people, access to the data in different environments? And if the types of data sets changes, then how do I ensure that the experience of the data scientist remains consistent across all the environments? Another challenge, for example, is dev environments are teared down very frequently. So I have seen a lot of companies who just routinely wipe out the dev environment and recreate the dev environment from saved templates, right? Which essentially means if I have trained a model and I have saved that model in a regular way, then that model repository is liable to be deleted at any point, right? So how do I create a repository, container repository, which I have to persist across the environments? So that those kind of things become a little challenging and little interesting when it comes to designing a system like this. But for ordinary data science users, I think these managed services do a fairly good job.
Perfect. And I'm just seeing Flavio has a question in the chat. He's asking me what the timeline from idea until final deployment in the environment is. Like when someone plans to implement a new algorithm or a new project, how long is that entire process, and in which phase do they choose to drop or scale the project?
This is for any project or the example which I was referring to?
I think it's for the example that you were mentioning before.
Okay.
Because you had said you had said that it was going from 6 months, was it, from like idea to prod?
Yeah. So in their case, I think systems were much more primitive than a regular data science environment. But for them, a main challenge was doing the feature engineering and getting those new features moved through different stages of their data pipeline and having those features to play around with. So remember that even with this customer, even with the systems, even though primitive, I think we are still talking about millions of customers, right? And each customer having multiple accounts, which means a few hundred millions of possible combinations. So their ability to experiment was a little weak, and the main reason for this weakness was around the data pipe itself. I mean, that was one large chunk of the time. And that itself took them about a couple of months to get that going. The next piece was running that experiment. So now that I have the data available in some environment, so their original setup was to once the prod environment has the new data pipe built, they would create a snapshot of the database, and that snapshot will be available for the data scientist to work with. So the snapshot at any point would be a month to a couple of months old, right? And they did whatever they could with that information. The building the model, etc., would take them another a while. And once they have that building, again to test it out, taking it to production would take them overall a period of 6 months. So this 6 months we had to shrink it to about 3 weeks. And the way we did it was basically implement all best practices available with the DevOps, MLOps kind of system, from the Spark codes, which go through a similar process, to the machine learning code, which again goes through a similar process, and have these two sort of allow the idea to experiment to scale from 6 months to, let's say, 3 weeks.
Yeah, that's a great success. You shaved off 3 months. I would imagine people are very happy about that. So,
yeah, I mean, in principle, yes, but you have to use it in a way so that it kind of allows you to do more experiments, right? So.
Yeah, and I'm sure in 5 years from now, we're going to be thinking to ourselves, wow, it took so long back in the day to get things into prod. But that's just...
Oh, yeah, sure. I'm sure. Yeah.
Yeah. Right now, we gotta do it. We gotta, trailblaze. So I see a question in the chat from Ravi. He's asking, once the model is trained and now it's in production, or it's production ready, as a data scientist, do you still continuously train the data when the model is serving live traffic?
Is it a question on... So the one thing that we test again, I'm not sure I understand this question completely. Ravi, can you just articulate that question or maybe clarify it a little bit?
Yeah, and Ravi...
but anyway, I'll try to answer to the extent I can. All right. So no, we don't train it continuously. That's not the idea, basically. In this particular case, you can have other setups where you try to train it continuously. Here, the most important thing to guard against is the idea of domain drift. In fact, another topic that I'm very passionate about is identifying this domain drift. So, what is happening over a period of time is I have trained my model on a particular data set under the assumption that, maybe a trivial example, but under the assumption that my gender ratio is 50-50, right? Over a period of time, due to some reason, this has skewed, and I have 70, 80, 90% women and 30% male in the actual data that I'm getting, or something else has changed in that model. Now, how do I detect that and guard against that is a point that we want to think about. So what we are trying to do, and this is an idea that I'm playing with right now, is to every batch of data that we score, or every batch of data that I have received as input to my scoring engine, I need to look at that data set and do a meta-analysis of what is available. And that should happen continuously. I may not train it continuously, but I should be sort of looking at that data set continuously and identifying what is a good time to retrain.
Yes.
Do I see certain parameters have changed? Do I, and this is a tough question, because it's very easy to just hand wave and say, if anything changes, then retrain. But define that anything. Define the quantity by what it should change. Define what is the period of time this change is relevant, etc., etc. You know, there are other nuances to it, and that's a fascinating topic. That, I think, is extremely interesting question to ask. Even for a system which is not supposed to learn in a continuous way.
Great. We got a few more questions in the chat, which is exciting. It means people are enjoying it. I like it. Bring on more questions if you all have them. I find this question quite ironic, because they're asking about how much do you think privacy and security measures impact the time to develop and ship production of a model? And it's an anonymous question. So they're asking about privacy from an anonymous source wants to know.
I don't fight with that. So there are certain metrics which I can influence. Those are related to machine learning. There are certain metrics or certain processes which I can't influence, and I don't typically engage with that unless I have good reasons to do that. So, and this InfoSec bit comes into that domain. I am not an expert in this area. There are regulations, there are liabilities which people who are smarter than me are aware of, and they design systems according to that. So even if it slows down my system a little bit, I would try to live within the constraints that I've set up. If I identify something which I feel is obviously irrelevant or not important, then I might go back and question on that. But as I said, I don't. Even if it slows down, I'll have to live with that. I honestly don't understand enough to say I don't care about the InfoSec.
Yeah, you got to pick your battles, right?
Yeah.
So Flavio's asking a great question related with COVID. How do you guys manage with the concept of drift? Are you working on that? Like, are you monitoring for any concept drift?
Yes, concept drift, domain drift. We are working. This was the point that I was just trying to make. That we are trying to develop systems which take a batch of data, compare that batch of data against a set of not preconceived, but some of it is historical, some of it is business. But so here's a gold standard of how my data should be, a profile of the data. And every batch of data which I'm getting now, today's scoring, today's scores, and I compare it in a way, and I try to understand: am I comparing apple to apple when it comes to accuracy, when it comes to model fairness, bias, when it comes to all of these nice things? And and that is something that we are working with. That is one approach that we are trying to use is we work with the business teams and we use historical data profiling to create some information at a meta level about the data batch. And we store that information, persist that information, let's say on GitHub for a period of time. And we monitor the new data which is coming in to our scoring over a period of days and months, and compare these two information together and try to identify if something has changed. There might be very smart ways of doing it. I haven't completely thought through it, but we as a team are trying to figure out what's a good approach to understand and protect against this. And I think the big risk for some of these, like COVID-19, is our model has been like COVID-19, for example. I'm sure you guys are experts in this area, but the distribution of COVID-19, the basic underlying theories about how the data is distributed changes as COVID-19 comes in. And a model which has been based on assumptions about distribution, like normality or stationarity or any of those things, is no longer valid. But how do I know it is no longer valid? COVID-19 is, of course, an external thing, and I have a flag which rings, hey, is my model valid with COVID-19? But otherwise, also domain changes. And having an automated way of doing it is probably a big addition to the MLOps process itself. So the idea of testing, the way DevOps people do testing in the DevOps world, MLOps should have this idea of domain drift to do the tests right.
Yeah, I completely agree with you on that one. And Flavio is also asking if you're using any strategies to defend against adversarial attacks in the model. For example, Blackbox attacks, pooling response attacks, this kind of stuff. Do you ever dabble with that?
No. So, no, I haven't. I understand the idea of adversarial attacks, but I'm not familiar with the concepts of black box attacks or pooling response attacks and so on. So I can't answer that question completely. But if these attacks can be understood through the lenses of what is input, then again we can have MLOps or we can include this in our MLOps process to ensure that we are protected against some of these things. But I have to research a little to understand what black box attack is to give you a better answer to this question.
Great. Yeah. So, well, I mean, along those same lines, I'm wondering about if in all of these years of you going into companies and helping them create their machine learning, have you ever seen or been involved with any big like mess ups? We could say, you don't have to give any names or just say the company that you were at, but where were some really big mistakes that you saw and how did that impact the companies and what was it that was the cause of that?
Big mess ups. I kind of I probably understand the type of examples that you're looking for, but I may not have a good example like that. But I can give you one interesting example, right? It's not a mess up, or maybe it is a mess up, I don't know. So you have to differentiate between the. So I was working with this with a small startup, and they try and help with grain classification. So the idea is, if you sample, let's say you have a big container of wheat, which has come into your place. You're like a trader, and you're trying to assess the quality of the wheat and buy the wheat from the farmer, right? Or buy the wheat from the dealer, supplier, whatever. You can't sample the whole set. It's like a few thousand kgs, kilograms of wheat. So what you do is you take a small sample, you put that sample on your hand and look at the grains there and make a judgment. And you're very good at that. That's how you make your money. Can we replace this with a machine learning system? Can we take an image of this sample and use that to estimate the price of per kg for that particular lot of grain? In principle, this sounds like an easy problem, and I think it is an easy problem from a classification perspective. So we got very good results when it came to our pipelines, our test train, great accuracy, great F1 scores, great model test accuracies and precisions and recalls. But when it went out to the field, we created equipment, we created scanner and so on. When it went out to the field, it didn't work very well. And the reason for that is the person when he holds the grain on his hand, he has three-dimensional view and he has a feel for that grain. He can touch the grain and think. I take an image, and I ask the same guy to look at that image and say whether it's a good quality grain or a bad quality grain. Based on that image, he gives some answers. Our classifier is compared across this answer which he has given, the answer which is on an image. But the difference of assessment between what he looks at when he takes that grain in his hand and what he can do when it looks at in the image are absolutely different. And even though our classifier does very well on an image, it could never replace the accuracy which people got by taking it into their hands. So if you look at the whole project, it's a big flop because it doesn't work. He's not able to, our system is not able to give him the exact measure of quality that is required. Yet, our computer vision system is doing a fantastic job of classifying. So, yeah, a lot of money wasted, lot of effort spent for no gains, but this is what happened.
Yeah, wow, that's great. Thank you for that. I see another question in the chat from Flavio, and he was asking what your thoughts are about differential privacy, and do you have some suggestions for those who are trying to implement that in practical arenas of MLOps?
What is differential privacy? Oh, okay, I have the question here. Oh, differential privacy as in different people have different access to the data set?
Yeah, I think that's where he was getting at. Yeah.
Okay. Yeah. So there is. Again, going back to the example which I was talking about, there is because of governmental regulations around data security and data control, etc. Different people in different countries would have different levels of access to the same data set. But so, for example, if we have a distributed team spread across 3 different countries, each of these countries would have different sort of accesses. And specifically for machine learning, I think it is critical that we create that ecosystem which has this sort of different systems. We don't have a great answer to solving this. But what we have managed to do is in the if you are using a data lake, then we provide access to different data sets according to the privileges of that individual. And that individual's privileges are determined by geography, national location, and a bunch of other things, which prevents him or her to access, let's say, personal data from a different country. So that kind of setup we have done. But this is more as an analytics application than a machine learning application, where people are using that data set to run their own business intelligence reports and so on. And there we give granular access to different people. But let's say to a machine learning engineer or data scientist who needs access to a larger data set, I don't have a great answer of how to solve that problem.
Yeah, and as you're saying this about the data analyst, this is the data analyst side, or this is this person's job. I'm reckoning with the question of what is this whole MLOps? Does MLOps even include the CPUs or the data centers that you're using, that the actual hardware, and does it go all the way until the model's in production and being monitored? How do you see that, where MLOps starts and finishes in that way?
The way I have seen most of my customers work is through a process of budgetary control over the compute resources which are given to different teams. So, for example, there's one customer that I have been working with for a while now, and each of their product teams have a budget, and they can spend that budget on different things. If they hire people, they buy equipment. They also have to put that amount or associate that the compute cost to that team. And the way they work is each team has been given a quota. So it's up to the team how they manage to optimally use their available resources. So basically, the product manager or the data science lead of that team um, thinks about before you move anything to a training pipeline. How do you ensure that this is a experiment which is worthy running? And they have their own internal, formal, informal processes of doing it. Uh, but they are very cautious. Specifically, so there is another trick which I have seen again people use. That is for workloads which are not very compute intensive, they use their own system. So they don't use the cloud to do the compute. But for heavier workloads, they have to eat into their budgets, and then basically the team lead sort of decides which is a worthy experiment to run.
Now, moving on, just a quick side question on that. Do you have much experience? We had 2 weeks ago or last week, I can't remember now. Yeah, last week we had Josh Bottom on, and he was talking a lot about Qflow. And I've noticed there's been a lot of traction with Qflow. Do you have much experience with Qflow, and can you speak to some of that and how it was?
And no, I don't have a lot of experience on Qflow. I have used Qflow in a bunch of in a couple of examples, but they were more hello worldish examples than proper development of Qflow. Based on my preliminary reading of how Qflow works, I think if you are very well aligned to the Google set of ecosystem, then maybe Qflow is a good approach to kind of develop your whole system on. But I know that most of these things are open source, etc. But otherwise, I have not used Qflow to a large extent to answer that question. Then.
No worries. And the other question that I had is, when does a company decide to bring you in? What is it? Is it when they say, okay, we want to get a model into production and we don't have any data scientists, or how does that look?
Mm. So we work with companies at different levels of the MLOps stack. In fact, in many cases, we have had companies who have asked us to help them set up their teams itself. So, what should be the right structure of my data science team? See, MLOps is a piece of a larger story of the scaling of machine learning. So, if you look at scaling of machine learning, scaling of I think there is a technical component of MLOps, a technical components of training and cloud and whatnot. but there is also a lot of behavioral process related issues, right, which have to be also tackled. So a bunch of cases we have worked with customers to set up their machine learning ecosystem, evangelizing machine learning itself. So start from there. Teach us what machine learning means. What can we do with it? Does machine learning mean you can predict when the glass will fall from my hand? Does machine learning mean you can give me at what second tomorrow there will be rain? Maybe, maybe not. So, what is the potential of machine learning? So starting from evangelizing to setting up teams to then creating concrete problems which can be solved using machine learning, and then putting together the compute, the know-how, the algorithms, the data sets required to solve it. So we work with clients in the whole spectrum. We also there are some clients who start from, let's say, level 0, level 1, but there are many clients who are fairly mature. So we have a bunch of customers in the west coast of US, in the tech services, who are fairly sophisticated. They understand everything. Some of them are inventors of a bunch of things that we are talking about today, right? So for them, hey, you come in as a data scientist. I give you this metric to optimize that metric, and then your job is done. So we basically work all across.
Yeah, the whole spectrum. And is there any sort of like pattern that you have noticed with getting successful use cases from these different people that you come and you consult with? It like maybe, oh, well, if there's an enterprise that's very engineer focused, then you can have a bit more success, or it's more likely that there's success. Or if it's a small startup and they're willing to learn from you, then it's probably going to be more successful. Have you noticed anything in that regard?
No, I think what I have seen is, as I was saying, there are some companies who have it either in their DNA or they want to build that. There are many companies who want to have that engineering capabilities in house, and they work with us so that they get an acceleration. We help them very quickly get to a certain point, after which they may choose to do it by themselves. Or they just want us. The advantage of working with someone like us, someone like me or my team, is that we see a whole diverse set of ecosystems, customers, types, and so on, and that allows us to give maybe a little more outside in sort of a view as to what they're trying to do, and that is something that customers look forward to. Many a times after that they decide to do things by themselves, which is also fine with us. But many a times they said, "Hey, you take care of this part. I'm going to specialize and develop whatever is my core business." I mean, it may not be data science at all, right?
Yeah. So we're reaching the end of the hour. I want to let everyone know, if you have one last question, go ahead and ask it. Otherwise, we will say a big thank you to you, Saurav. And I really appreciate you taking the time to talk with us about your learnings and your knowledge on MLOps. It's pretty obvious that you've done this a few times. You've been around the block, as they say. So yeah, the last thing I'll say is, if you guys aren't in the Slack, feel free to join it. We'd love to continue the conversation there. Saurav, what's the best way to reach out to you if anyone wants to continue talking?
LinkedIn, I think. Best place to reach out to me is LinkedIn. I will join your Slack, so that could be another medium where you could reach out to me. But otherwise, I'm always available on LinkedIn.
Great, perfect. Well, I wanted to say thank you once again. It has been awesome, and really, you've been able to expand your knowledge to all of us. I know that I've benefited greatly from it, and judging by the amount of questions that are in the chat, I'm sure people were really interested and were able to find some value in it also.
So, thank you so much for having me. It was great talking to all of you. I enjoyed being here, and I hope I'll be able to contribute to this community a little bit more. I haven't been very active here.
Great. That's what I love to hear. That's very exciting. So take care, everybody. We'll see you all later.